very good morning, afternoon, and evening to all of you folks. I am excited to see you all, and I noticed we have people from across multiple time zones. And I want to thank you all for taking the time out from this busy schedule of yours to attend this first rapid hiring event from Guidewire. I'm here to talk about what my teams do and the challenges along with the opportunities we're planning to scale over the next year or so. However, I'd like to also set the expectation that even though I'd be giving a lot of technical details, this is not a tech talk because I'm not going to be delving deep into any particular area of technology. But at any time during the course of this presentation, if you think any particular technical topic you feel we should do a tech talk about, I encourage you to please mention it in the Zoom chat, and we will take note from there. I also wanted to mention that we are conducting more of these hiring events. My peers who are managing different areas in product engineering will be presenting their unique challenges and opportunities that their own teams are facing over the next few months. So please be sure to follow us on LinkedIn to get the latest updates to all the future events. Now, without further ado, let us start the presentation. And if I can get Zoom to work. All right, what's the agenda for today? I'm going to talk very little about Guidewire. I promise you this is not a market lecture. So my aim is to get into technical details as much as possible. Next, we'll talk about ATMOS. ATMOS is our platform as a service that we built in-house on top of Kubernetes, as well as the related ecosystem around it. We'll talk about the technical roadmap that we have and our working model of how we work, how we approach work, and the opportunities that you might be interested in joining us for. All right. So, as I promised, this is an eye test, but in any case, I'm going to start with, for those who don't know what Guidewire is about, we are a software provider in the insurance, P&C insurance space. For those of you who don't understand P&C, it's property and casualty, anything that's other than life and health related. So things like, insuring your car, insuring your business, your home, etc. We provide the softwares which are then used by 400 plus insurance companies in the world across 30 plus countries. We've also been extensively covered by Gartner, being part of their Magic Quadrant leaders in certain areas of our insurance space. All right. That was all about Guidewire. Now, let's talk about what Guidewire Cloud is about. Our main aim with regards to how insurance core systems work till maybe a decade back was people would buy insurance software, run it in their data centers, build an entire DevOps ecosystem, Snowflake to their interests. And we took a fresh approach to this in 2018. We started off in 2018, late 2018. And I would say our beginnings were mostly in mid 2019, where we were able to conceptualize a platform on which we could provide our customers with not just hosting services, right? The first step was, okay, how do we de-risk our customers from being able to host and run an entire gamut of tools, but also provide incremental value-added services on top of the cloud. So we are currently running on top of AWS, where we have built an entire cloud infrastructure services platform, which then provides additional value-added services like, DevOps on top of it, digital services, platform for building out your UI, UX, your data platform, and then on top of that, you have the tip of the iceberg, which is the insurance platform, which is then used by the insurance customers to cater to their consumers, right? And that's the entire idea behind what Guidewire Cloud is. But in addition to that, our the strategy was obviously to make it easy to adopt, operate software in production, make the work of our developers as effortless as possible. We want to assure that the success of the customers going live on the Guidewire Cloud platform is an ongoing, secure and stable platform where they can expect Guidewire to keep up to the trends of what's happening in the industry. We want to enable our Guidewire Cloud business to scale so that, for us, we get economies of scale, And at the same time, we're also providing our customers the option to scale along with us. So these were the primary goals of why we built the Guidewire Cloud Platform. Now, if we were to zoom in, skip the slide though. If we were to zoom in, the Guidewire Cloud Infrastructure Services is basically what we call ATMOS. ATMOS is a Kubernetes-based platform which runs on top of AWS. We provide isolation for customers, between their own environments, and obviously between customers themselves. We provide the ability to provision services, which are cloud or non-cloud services, things like, hey, I need a database, versus, hey, I need a streaming service, versus I want an integration system. All of those are present as part of our ATMOS ecosystem. And we provide a way to provision them easily for our customers. All right. Again, just diving a little more into what are the key services that ATMOS provides, we provide tenancy, we provide networking, things like, how do I do MTLS between my insurance software that is running on GWCP with, say, a third-party system, or with my own internal systems? How do we provide networking in terms of egress? How do we put limits to the egress? How do we make sure we're not sending spoofed messages from within our systems? How do we control our ingress in terms of how do I validate where the request is coming from? How do I make sure that we have trusted domains, etc. Then the most important one is security, without which I don't think any of our customers would trust us to run their systems. Security is at the core of what we do. It includes everything from not just providing secure access to secrets within the system, but also about the entire process around how we build, deploy, and operate our systems, right? How do we provide the least privilege policies, enforcements, and making sure that we are up to date with regards to most of these attack vectors that come out in the wild. An example I can give is if you guys remember Log4j. Recently, we've had an issue with one of the dependencies. Log4j is a widely used Java library, and there was a very easy exploit that could have affected all our customers. But thanks to us running this as a platform, we were able to introduce a Java agent, which could then do a runtime bytecode weaving and change the affected code inside a third-party library across all our Java applications running in a platform. So in one shot, we could take away the attack vector for this domain just by making one change at the platform level. With regards to processing, which is about compute, we obviously use Kubernetes as our primary processing agent, but then obviously there are other AWS services that we consider as well. Lambdas for one. Storage management, again, it's all about EBS, EFS, file storage, block storage. All of those are also present through our ATMOS platform as service. So applications when they run, they have the option to choose the sort of volumes that they want to load onto their applications. Cool. Now, getting back into how do people use ATMOS, there are two primary goals of, two primary ways that ATMOS is used within Guidewire. One is for our customers, and the second is for our internal developers. Now, for our customers, we front end ATMOS by using a good UX that is developed by my peers based in Poland, and customers don't directly interact with Kubernetes. Instead, they get a wonderful UX through which they can do all their DevOps activities with regards to building, packaging, deploying, CI/CD, etc. All of those through that UX. Packaging obviously is done as part of the CI process, and then CD is through our own UX, which uses Argo CD behind the scenes. Now, when it comes to internal developers, we give them more unbridled access into Atmos, which is they are able to use kubectl commands, etc., to be able to do the things that they want to do. And we give them a standardized, the question comes begin, why do you need Atmos? It is providing a standardized model through which we can operate efficiently. Because the key thing is installing something is very easy because that happens only once. You do it on day one. But day two is what's always hard because that's forever. You have to continue to maintain it forever. And that means you have to put as much effort in building out a process or a platform that is able to take in these changes and are able to you're able to maintain it going forward. Right. And obviously it doesn't stop there. We provide things like service discovery, mutual TLS, automatic retries, circuit breaking, fault injection, zero downtime. Now, these are all terms which many of you may be familiar with, some of you may not. Diving into each one of them is a topic on itself. So I'm going to take some of the key areas that we've been working on very hard for the past few years, and some things that we might be working on later. For example, mutual TLS. Mutual TLS is a way through which we can identify both the server and the client, trying to talk to each other, right? And this is by using crypto keys, etc. And we've used Istio as a way to produce egress level mutual TLS. And we use other API ingress software to be able to do mutual TLS on the ingress side. We have automatic retries. So let's say an API call comes in and that's failed. There's automatic retries to X period of time or X number of times before we fail. We try to do dynamic routing, A/B testing. Now, this I'm going to admit is something that we're still grappling with. We're not entirely solved it. This is a way where I want to introduce. I already have V1 of a software running, and I want to introduce V2 version of the software. How do I make sure that I introduce V2 in a way that I'm testing V2 on live customers, X amount of customers, making sure everything is working fine, and then automatically following through the traffic from version 1 to version 2, transparently. Container security. Now, this is like I said, security is one of the key elements within our within Guidewire, and especially so within Guidewire Cloud Platform, because we are now responsible for our customers as well. We do a lot of testing post deploy using tools like Twistlock, etc. But we are also shifting left a lot of those responsibilities, as in how do we make sure that what gets deployed is verified beforehand at the developer time, because it costs us much less to fix something at dev time than it is to fix something that's already in production. So we've shifted left a lot of those using our CI tools internally. DR is multi-zone support is something we already have because Kubernetes gives us some of those native capabilities, but we want to extend that. That's more like HA, but DR is something that we want to extend beyond region. Let's say an entire AWS region goes down. How do we survive that attack? How do we survive making sure that we can transparently move our customers over into a region that is not affected? So those are things that we're working on. That's not entirely solved, but these are things that we work on. So moving forward, what do my teams do? So my teams build out Atmos, and Atmos is split into multiple teams. There's a team that manages persistence within Atmos. There's a team that handles networking within Atmos. There's a core Atmos team which focuses on compute and IAM. There are teams that are based there whose focus is primarily on multi-tenancy to make sure that we have the proper level of isolation. So there's a tenant-based team. In addition to that, we also have teams that do DevOps sort of work in terms of, hey, my internal developers need to create a microservice. Now, instead of trying to do something from scratch and then try to build towards standards, we have a tool where you can give your intent and you can give your domain. And if you were to give your domain entity, then it would generate for your entire Spring Boot Java web application. that would adhere to all our standards, both security as well as the best practices in the industry. So you're bootstrapped and you're able to go from zero to a deployable artifact in production with CRUD services, create, update, and delete services in a matter of minutes. But of course, you want to do beyond that, where you want to build your services, which is beyond CRUD. So we have tools like that. We have services that do authentication and authorization. So that makes it easy. This is a common service, right? This is a cross-cutting concern for every team that's working out in Guidewire. So how do we solve that once and for all for everyone? So we have teams that work on those. We have build tools, which is about release engineering plus tenancy. So we do all of that. We have centralized property service. So this is an interesting service where we have a property store that is used by every single system out there, and we have different layers of access into those properties. So you could set things at Guidewire level, or you could set it per tenant level, or you could set it per region level, or you could set properties that are that could be affected for the running microservices or applications or core applications that you could change in one place instead of having to change it like 100 places at the same time. All right, so where are we? So just giving you a glimpse of, we started sometime in 2019 or so, and what I'm showing you, the numbers here are in our dev. Our production is much higher than this. So we have about close to 34,000 running containers. Our infrastructure has about 613 nodes or hosts, EC2 instances. And the pods or the running applications are around close to 8K. And you can see the difference between desired and available, and that's primarily because this is in dev. So there's obviously some things that is not off the mark, and we have about close to 400 or so pods that are not working as expected. What are we going to do next? Now, this is what I think you should all be interested in. The primary aim for us is, how do we secure an entire supply chain of software? How do we provision infrastructure in a much more robust way? How do we manage clusters in a through a control cluster? I'll come to that pretty soon. Observability is a key aspect to everything that we run. We want to be able to also identify costs and give showbacks, as in terms of other teams who are using ATMOS, they should be able to understand how much it costs to run their services. And then functions as a service. How do we make sure that we can run some of these things which can, which are not huge microservices, but nano services or functions that you could easily deploy and run. All right. So the first problem that we had with ATMOS is, we built all of these different modules, and we use Terraform, and they're all there as modules, but the deployment model was very monolithic. So I would deploy everything in one shot, and which means, if anything goes wrong, the time to deploy takes even further. And we try to reduce that into something where we can use technologies like Crossplane or Kubevela that will abstract a lot of things for our operators. Our primary goal here is to reduce the amount of effort for our operators to be able to deploy new clusters, new software, new cloud services, etc., by giving them the option to do things, in a much more easy fashion. Instead of having 1,000 knobs to turn, how do I reduce that to the 10 knobs that actually make sense, and use intelligent defaults for the others? And also, we want to get to a point where we can enable each of these ATMOS teams to be able to deploy at their own pace, and that thereby we're getting the economies of scale with regard to the deployment times, right? And you can stagger deployments at different times. All right, multi-cluster deployment. So to give you a little bit of scale, we have around 32 different clusters running in different areas and regions of AWS. Maintaining all of them is not an easy task, right? How do I make sure that I can reduce drift across all of these clusters? In order to do that, one way we figured out is how do we use a control Kubernetes cluster, which can constantly look, in a control loop for each of these other clusters which are running applications, and make sure that they validate and reduce the drift as we move forward. And you know what? Once we get there, the control cluster could deploy in multiple cloud providers as well. So that's one thing that we'd be looking at very closely for the next year. Again, this is just speaking to a point where initially we had each cluster which had its own Git repository and was managed by our operations team. We want to get to a more GitOps model where entire clusters, including everything, if you look at it, the stack, it goes from down to the cloud provider to Kubernetes, plus all the other operators that we build and third-party operators that we run in Kubernetes. How do we make sure that all of that can happen in one shot through a controlled Kubernetes cluster? And instead of having to do that piecemeal per cluster for operators, makes it easy to consume, easy to produce new clusters, as well as tear down, make it ephemeral if needed. We could apply all of those principles to get there. Now, secure supply chain. Why secure supply chain? In the recent past, attack vectors are becoming very complex, where bad actors could affect anything from source code dependencies to your supply chain in terms of your CI/CD to where you deploy, right? So having an entire process where we can make sure we are secure and we know that we have secured or know that nothing has changed is very important. So we are actively working. What we're doing currently is we do threat modeling, we have architectural reviews, and then we run our software through DAST or SAST, which are static code analysis or dynamic code analysis as part of CI/CD. And after deployment, we check for changes in the containers. Now that's all well and good, but we want to be able to get to a point where we can audit across, and we want to be able to use immutable infrastructure and as well as a deployment manifest. So how do we go from knowing what is deployed in my application, including all its dependencies, being able to trace back, use something like automatic dependency management, where we tried this once, where we automatically updated the dependencies of our applications, but that caused further issues with regard to compatibility, etc. But we want to get to a more robust state where we can inform the teams who are using this software that, hey, a new version is out, you can click this button and get updated. How do we make sure that we have a software bill of material to know what is deployed, what is running, right? How do I get the information about what is running? And the next one is about containers, right? Our primary deployment model is containers on Kubernetes. How can I at scale, let's say I have 100 containers running in my cluster. It's not 100, it's much more than 100, and there is one particular layer in the container which needs to be replaced. Now, asking all the developers to go rebuild and retest and then deploy, which is going to take a lot of time, how can we rebase a single layer of container across the cluster for all the containers that are running which have an issue or a security vulnerability in that layer? So using build packs or K-pack, we'd like to address that. And the second thing is next thing is about deployment time policy enforcer. How do we make sure anything that is getting deployed has gone through all the necessary checks? It has all the necessary information before it can be deployed. So we're looking at validating hooks in Kubernetes. There are tools we're looking like K-Rails, OPAS, Gatekeeper. There is JS policy from Loft, etc. We're looking at those things to be able to validate and making sure that anything that gets deployed is actually valid to be deployed. In all of this, we also want to be able to have pervasive metadata about everything that's deployed. So think about this. An auditor comes and asks, hey, what you're running in production, has it gone through these tests? How do you know that this has gone through penetration testing? Has it gone through SAST or DAST? Now, apart from just showing our CI/CD, I'd like to get timestamps, audit about everything that has happened, state management of with respect to security for a particular container or an application. And so we'd be using something like Prometheus or Graphias from Google that will help us get there. Observability. Now, this is interesting in the fact that, hey, I have an application. Now, let me talk about why. I have an application. I've deployed my microservice in Kubernetes, and I want to know what's happening to all the application. Now, every team can build their dashboards in Datadog, which is our primary observability tool. But we want to make it easy for them where, you know what, when you deploy something, we have a Kubernetes operator that will detect that there's a deployment that has happened and will automatically create a dashboard in Datadog with standard palettes and standard dashboard, which has all the information needed. So they're bootstrapped from day one when they deploy in production. You know, it gives all the information with regard to alerting, metrics, performance, trace, error counts, etc. Cost attribution. This is another problem we've been grappling with. We have internal teams as well as customers who run, and we want to get to a point where we can show back for our internal teams basically the cost of running their service, so that they can make design choices to be able to do things better and right, and get granular to a point where it will actually help them to do what they want to do. Functions as a service is another thing we're looking at. How do we enable them through Kubernetes, using tools like Knative or OpenFaaS, etc., to be able to run Kubernetes serverless workloads in ATMOS. All right, a working model. How do we work? We believe in empathy and collaborative working. We do pair programming. That's day in, day out. We do rotations almost every day or every other day. We believe in ruthless prioritization, continuous improvement. So we have days like upskill day in every sprint where everybody spends some time trying to figure out what are the new things that they would like to do. We provide every one of our employees with a mind time. So they have, because they're pair programming, they get an amount of self time that they can do what they want to do. We hire for aptitude, potential, and skill, right? In that order. We believe in learning, having fun, produce value for customers and for the teams around, and to grow.